Hi class, this is course 2, lesson 4. Today we need to talk about number line and sequences. So let me get my title all nice and fancy here for you. Number line and sequences. So there's quite a bit of material here, and we'll go over it a little bit better in class. But what I need you to do on your notebook is to draw a number line, and we're going to put 0 right in the middle. And on the right hand side, those would be the positive numbers, 1, 2, 3, 4, etc. Remember, those are counting numbers. I'm going to label this. These are positive numbers. Okay, and then on the left side, we do the same thing, but we're going to put negative numbers. So we have -1, -2, -3, and -4. And again, I'm going to label this as negative numbers. Okay? Okay, remember that on the left side, those would be values that are less than 0. And on the right side, these are numbers that are greater than 0. And everything is kind of centered around that 0. 0 is right there in the middle. And we can also call that the origin. And here's a really big thing that you need to remember. The origin, or 0, is neither positive nor negative. Okay, it is neutral. I'm going to put a nice box around that so that I remember that. 0 is also called the origin, and it is not signed. It is neither positive nor negative. Okay, and so what we just illustrated there in that number line are the integers. Those are all of the counting numbers, 1, 2, 3, 4. Their opposites, so -1, -2, -3, -4, and on in both directions, and 0. Okay, and to write that set notation, we can do the brace. We're going to do the ellipsis. We're going to put a comma there, and then we're going to start with the leftmost number, -3, -2, -1, comma 0, comma +1, 2, 3, comma, ellipses, and braces. Okay, and I will just make another note that that is braces, and these are ellipses. Okay, and those just mean that the set goes on forever. Okay, so this is the set of integers. Okay, I'm going to flip the page and we're going to start a new topic here. We are going to compare. So if we use comparing, if we're going to compare numbers, we're going to use comparison symbols, and they look like these right here. Okay, so I made a 3-column chart, and I put this symbol in the far left, that is less than. So the values on the left are less than the values on the right. 4 is less than 6. -2 is less than 0. -5 is less than -2. Equal to, that shouldn't be anything that you are not familiar with. 3 equals 3. We can also write equations that look like this. 6 plus 1 does equal 7. And -8 equals -8. Greater than means that the number or the values, the expression that is on the left, are greater than the expression on the right. So -1 is greater than -8. It is further to the right on the number line than -8. 15 is greater than 0, and 3 is greater than -3. Another topic in this lesson are sequences. And any sequence is an ordered list of terms following a pattern or a rule. There are 2 different types of sequences. One is an arithmetic, but we call it arithmetic sequence. Same number is added to each term to find the next term. Those terms are equally spaced apart. And I have a nice little arithmetic sequence right here for you. 3, 6, 9, 12, and it goes on and on and on. What I want you to know is that this is term 1, term number 1. This would be term number 2. This would be term number 3. And it goes on and on and on. Okay, so each number has a value, 3, 6, 9, 12, and it has a term number, or the position in the list, 1, 2, 3, etc. Okay, so now all sequences will have a rule. This rule in words would be, well, what are you doing to each number to get the next one? 3 to 6, 6 to 9, you are adding 3. So we're going to write add 3. And then I can also write an equation. And the equation will be k equals three n. Okay, now I didn't add in here, did I? But repeated addition is shown as multiplication. And now you're probably wondering, what is k and what is n and how did that happen? Well, k is the sequence value. Okay, that's the output. And in our example, it would be 3, 6, 9, 12, and it continues. N is the term number. Okay, so what position does it occupy in the list? And those were 1, 2, 3, 4, etc. Okay, so how does this work? If I have this equation, I can put the position number, substitute that position number in to get the sequence. So if I take k equals 3 times the first position number, I get 3. If I take k equals 3 times the second position number, then I get 6, and it would go on and on and on. Okay, so hopefully that helps, and we'll go over that in class as well. Now, another type of sequence is a geometric sequence. Terms are not equally spaced apart. Okay, so here's an example. 1, 2, 4, 8, 16, etc. So notice that the difference here would be 1, then 2, then 4, then 8. So they're not equally spaced apart. So these are a little bit trickier to figure out the rule for. But one very popular and useful sequence is the list of perfect squares. So we have a list of perfect squares, and what the rule here would be k equals n times n. So what this means, same thing, k is the value, n is the position number. So the list would be 1, 4, 9, 16, 25, 36, and that list will go on forever. The first one would be 1 times 1, position number 1, 1 times itself. Second one is 2 times 2, the second position. The third one is 3 times 3, the third position times itself. 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9. Okay, this list will be very important to you as you do some of your lesson activities. Okay, that's all I have for you in lesson 4. I'll see you in class.